Hello, everyone. Welcome. Thank you for joining us this afternoon. So, for those of you who haven't met me before, my name's Helen Spiers, and I've been organising this webinar series as part of the efforts of CCP-volumeEM. We're also joined today by Martin Jones. So, he's also co-host of this webinar, and he is PI of CCP-volumeEM. So this session is the third webinar in our new show and tell series, and I'm pleased to introduce today's speaker, Dr. Piper Fowler-Wright from the Rosalind Franklin Institute. Today, Piper is going to be introducing us to Jupyter Notebooks for shareable research outputs. So within his talk, he's going to cover how to get started with installation and basic usage, and also cover best practices for creating clear, reproducible, and shareable research outputs. Piper is a research software engineer in the Rosalind Franklin Institute's Advanced Research Computing team. He has a background in light matter physics of organic systems and has contributed to open source developments of multiple Python packages. He's currently involved in our CCP volumeEM project, and he maintains the RFI containers for common volume EM software, including Napari, iMod, Moby, and MIB. So with that, I'll just want to add that we'll leave some time for questions at the end of his talk. So please do add them in the Q&A tab as we go along, and myself or Martin will read those out at the end of the session. And also just to note that this session will be recorded and we'll be sharing it on the CCP volumeEM YouTube channel. So with that, I'll now hand over to Piper. Thank you, Piper.
Thank you for the introduction, Helen. I'll just share my screen so we can get started. Okay. Yeah, as Helen mentioned, I'm a research software engineer from the Rosalind Franklin Institute and on the Harvard campus in South Oxfordshire. And I started working with the Volume EM CCP last year. And my work is mainly concerned with the containerization of common Volume EM software. And that helps improve the accessibility and usability of that software. But today I'm going to be talking about another way to improve the accessibility or shareability of your outputs, and that's using a document format called notebooks, in particular Jupyter Notebooks. So if I just give you a quick overview of what I'm going to be covering, I'll start with the very basics about introducing what I mean by a notebook and also the Jupyter project, which is the most popular provider of this notebook format. I will then go through how you can install Jupyter and get using it yourself, and cover some best practices and other tips and tricks. And then towards the end, I'll look at more at how different extensions to Jupyter, how you can add extra features to your notebooks, and also some additional tools or alternatives which you may want to consider in your workflows. So I should say that pretty much everything I cover through these slides. I've made a little document with some links which will be shared with you on our GitHub organization or on the volumeEM website, together with the slides themselves. So don't worry about trying to get everything down or making notes. That will all be available. I think Helen's posted a link for us to everyone in the chat as well. Thank you. As well as a recording on YouTube. And yeah, please do ask questions. I think there'll be time at the end. Okay, so what is Jupyter? So Jupyter is the fifth planet from the sun and is the largest. Hang on, that's the wrong Wikipedia page. Jupyter is an open source project for web-based interactive computing. It includes the widely popular Jupyter Notebook application, which originally targeted just Python code. Okay, so let me just firstly start by what is a notebook. So put simply, a notebook is a document format which combines computer code and plain text. And this is very often used to show data visualization or interactive widgets. Now, the most common type of notebook are Jupyter Notebooks and Jupyter Notebooks in Python. But it's really important to note that notebooks are not just limited to Python. So Jupyter can support pretty much every single modern language. So R is another really popular one, but also C++, Julia, and many others. And beyond Jupyter, there are other notebook formats, which I will discuss more as we go along. But as this is the most popular one and the most likely you're going to be using and sharing, just for this session, I'll be mainly focusing on Jupyter Notebooks in Python. So the first distinction we need to make is between Jupyter Notebook and notebooks. So as I just said, the notebook I'm going to use to refer to this document format, which is just a document that combines computer code and text. Whereas Jupyter Notebook is actually an application for running notebooks. In particular, the notebooks from the Jupyter product have this very characteristic file extension, IPyMB. I'll have a look into more details on what that means in a second. But if I could just summarize what I've just said in the last couple of slides, this talk is going to be about notebook documents, but I'm using Jupyter as the main example. So another distinction which often causes confusion with people is the difference between Jupyter Notebook and JupyterLab. So these are essentially applications which serve the same purpose, but JupyterLab is the more modern successor to Jupyter Notebook. And I would say in general, if someone says Jupyter, they're normally referring to the more modern JupyterLab. So compared to Jupyter Notebook, JupyterLab has basically some more IDE-like features, so more like a code editor. So you can they have this workspace, and you can access your files directly from the user interface. And it has extensions such as real-time collaboration and plugins, for example, including Git integration. Now, another distinction is that Jupyter is not just limited to notebooks. So the project is called Project Jupyter. It's an open source project, and it includes other applications. For example, there's Jupyter Hub, which is basically a multi-user version of JupyterLab. So this is relevant for people who want to deploy this at their institution for many people. There's a Qt console, which is like a lightweight desktop application, as opposed to just running it in your browser. And there's another tool called Voila, which is actually lets you run notebooks as standalone applications. And I will touch on a couple of these a bit more later on as I look at sort of extensions and how you can share your notebooks. Okay, so just delving a little bit more into what notebooks are. So on the left, there is a screenshot of a Jupyter Notebook in JupyterLab. And this is actually a C++ one, just to illustrate that it's not limited to Python. And I can tell that because there's this C++, but also this code is clearly not Python. And this is what you see in the front end. And normally, or pretty much all the time you interact with Jupyter Notebooks, you'll be looking at these boxes, which are called cells. But actually underneath, Jupyter uses this format called JSON, which is for those who are not familiar with, it's basically a human readable way of showing objects in plain text format. So in a structured plain text format. But yeah, human readable definitely comes with an asterisk, because I don't know anyone who would actually read notebooks in this way. So, but just so you can, I think it's quite helpful just to see what actually goes into a notebook. This is the IPyMB format. So at the top, we have basically some metadata about the notebook. So this is telling me that it's running C++. That's the programming language. There's some version information, and then there's a list of what are called cells. So that's what these refer to, these boxes on the left-hand side. And each of them have some identifiers, but mainly the main thing comes in this source parameter, which is actually the computer code which is going to be run. But what I want to highlight here is that within each cell, the output of the cell, in this case, hello world, is also stored. And that's really worth bearing in mind when you come to share notebooks, is that if you've generated outputs, that output is going to be included with the notebook you shared. But I'll show you how you can clear outputs as well later on. But that's just worth bearing in mind that things can get messy quite quickly, given that your notebook contains not only the things you input into it, but also outputs you may have generated. Okay, so why would you want to use notebooks? Basically, the main reason to use notebooks is it's a really good way of sharing research outputs, which include combine both code and explanations. Um, this is because they have a very nice structure which lets you add explanations to your code snippets and your analysis um, in a very nice flowing way to really give your work a nice narrative. And that's a lot more digestible than giving someone just a plain Python script or even just a lot of text in some documentation or a paper. They are particularly strong when you want to enable some kind of interaction or data visualization. So if you have a lot of results you want to present with some nice charts, or you have some method or tooling you wanted to demonstrate where people can change parameters or modify it very slightly, then notebooks are great for that because they provide a sort of interactive coding environment where you can provide most of the structure, but then they can play for themselves. The other category of cases where I'd say they're very useful is for education. So if you're doing teaching or you have assignments to give out, then notebooks are a very good format. You can either do sort of fill in everything and make a sort of a walkthrough to demonstrate maybe the program you've written, or you could have more of an exercise type format where you fill in text some questions and some exercises to do, and they have to then enter the code and try and complete the exercise. However, notebooks aren't good for all use cases. So basically, you should never use notebooks when your code is very complicated, or you want to do some actual computational pipelines. So, for example, you wouldn't want to run a web server or do some sort of multi-processing computations in a notebook. They're not suited for software development. And this is for a number of reasons. But whenever you have multiple files going around, notebooks are not a good way to write packages and store that information because that's not a format that's going to be usable by anyone else who wants to use your package. And you also have other problems such as notebooks, because of this underlying JSON, notebooks do not play well with Git and version control. I would say, to summarize, notebook code in your notebook should always be short, simple, and sweet. If it's not those things, then you should probably reconsider if it's right to be in a notebook. However, that's not to say you can never showcase the result of complicated code in your notebook. And I'll show you in a second how to manage the cases when you do have more involved methods or complicated backend that you want to illustrate in your notebook. Okay, so I think it's good we just have a start about how we actually get working with Jupyter Notebooks on your system. So essentially, Jupyter is installed in a single Python package, just called Jupyter. And this is a meta package, so it actually includes a number of different applications. So that includes the classical older Jupyter Notebook, but also the more modern JupyterLab. And there's some extra conversion tools and other packages. So here I've just used Conda to create a new environment, and then Conda install from the Conda Forge repository. But it's also on the Python package index, so I'll show you how to install it using pip. And you can install it into your global environment, but I would say it's a very good practice to always use virtual environments when you can, because it keeps your system much cleaner and avoids dependency conflicts. Now, there is a really key point about using Jupyter, is that when you're in the Jupyter Notebook, if you want to import another package, for example, SciPy or Matplotlib, if you want to just use it, the easiest thing to do is you want to install that package in the same computing environment, Python environment that you install Jupyter. It is possible to add, if you have multiple system with multiple different Python environments, it is possible to add a kernel from different Python environments to the same Jupyter, a different Jupyter environment instance. And I think in the links I shared, there is information on how to do that. But the simplest thing to do is definitely just have them all in one environment, and just install Jupyter in different environments if needed. So once you've installed Jupyter, you can basically just run either Jupyter Notebook for the old version or JupyterLab for the more modern thing. So I'll just demonstrate this on my system right now. But if you want to follow along or have a quick look at yourself, you can go to jupyter.org/try, and you can actually start a JupyterLab session on their own servers. It might be a bit slow, especially if I try to do it once, but they have some nice examples on there for you to look at maybe in more detail later. So I'm on a Mac, and I'm going to make a notebook directory. But what I'm going through should work on any Mac in the terminal, any Linux machine, or if you're on Windows, you can just basically use any Unix compatible application, for example, Windows Subsystem for Linux or Git Bash. So what I'm going to do is I'm going to actually use Python's virtual environment package to make a Jupyter environment, a new Python environment for my Jupyter instance. I'm then going to activate this. So this is the equivalent of what we did with I had as conda create and then conda activate on the slides. And once I've activated this, I can just do pip install Jupyter. And so what I'm going to do is I'm going to also install matplotlib and numpy just to show you how we can access packages that are installed in the same environment. So I run this, you'll see that actually quite a large number of things are installed. And that's, because Jupyter itself has a lot of dependencies, and it is a meta package, so it does include a number of different packages within it. Okay, and then as I said on my slides, once you get to this point, starting the Jupyter instance is as simple as writing Jupyter in lab. So let's just see. And what happens is it actually is going to open up in my browser automatically. But if for some reason it didn't, then you can go back to the terminal and you will see there will be some URLs you can copy and paste into your browser to access the server. So this is localhost 8888. And there's also, you'll see here that it says you can use Control-C to stop the server. However, while you want to keep using the Jupyter Notebook, you're going to have to leave this terminal open. If you close the terminal, then it will also shut down the Jupyter server. So it's really important not to do that before saving your work, for example. So this is what JupyterLab looks like. And inside this, to start a new notebook, you can just click on this Python-free IPy and this will bring you into, by default, it's called Untitled Notebook. And before I go on, I just want to point out one really important thing is that the Jupyter server starts off in the directory or the folder where you launch the Jupyter command, where you ran the command from. So this is really important and unfortunately in Jupyter, there's no way of going up the file system. So I can't go up into my documents, for example. I'm only working within that subdirectory notebook subdirectory I created. So you have to make sure that you always run the JupyterLab or Jupyter Notebook command from a place where you can access your data or your other notebooks you're already working on. Otherwise, you won't be able to see them in this browser. Okay, before continuing, I just want to give you a quick introduction to what the key components are of Jupyter Notebooks. So essentially, there's two types of things you can get in a notebook. One are these code cells, which in this case we're going to enter just Python code, and the other are what are known as markdown cells. So code cells are just written in plain Python, and to execute them, to run the Python, you can just press Shift plus Enter or press the little play icon in the Jupyter user interface, and then a little number will appear by the cell, and that tells you that indicates in what order the cell was run. So in this case, this is the first cell that was run when I took the screenshot. Markdown cells. So markdown is essentially just plain text with a bit of extra syntax added. So for example, a single hash gives you a header, two hashes give you a subheader, and this is very common in a very common standard pretty much all over the web. I think Jupyter uses essentially what's known as GitHub flavored markdown for people who are familiar with working on GitHub. But if not, it's very straightforward, and there's a link to read more about all the different types of formatting you can use, so that when you run this with Shift plus Enter, you get this nicely formatted text for people to read, and the original will disappear. So before moving on, I'll just go back to demonstrate these in the notebook. So I also want to show that the packages we installed, which was NumPy and Matplotlib, are here. So let me just try to import Matplotlib, pyplot, and then to run this, I'm going to press Shift plus Enter. There's also a button here which you can run the cell. So while it's running, there's a little asterisk, and then it goes to 1. And that roundabout error. So I can now try and plot something. Just try and plot a straight line. And then plt.show. And then the graphic, the figure appears directly in the notebook. And so if I just show you what a markdown cell is. So in order to use a markdown cell, you actually have to change the cell type. So as I said, there's two different types of cell. So at the moment we're on code, and that's the default. That's why I didn't have to change anything for these first two. If I want to write text, then I'm going to select markdown. And now in this box, I can enter markdown formatted text. Sorry, just gone off the. So I can enter markdown formatted text. So one thing you can do is you can write code with backticks that's monospace formatted, and you can write, for example, I think you can write quotes with colon characters. And then you can see when I press Shift plus Enter, the text is formatted. So that is what really lets you add explanations next to your figures and your code. Okay, I'm just going to pop back to the slides. So now we've seen that why we want to use notebooks and how you can get started with them. What are some good tips? So the first problem is about how you can make your notebooks reproducible for other people. So how people can repeat the code when they run a notebook. And the biggest problem that comes up here is that the state of the Jupyter kernel, which is the Python process, which actually is responsible for executing the code, is basically shared between all cells of your notebook. And this causes a problem because it means that if you define or change a variable in one cell and then try to use it in a different cell, then that might give you different results depending on what order you run the cells in. And this is a problem if you're just sort of loosely filling out the notebook and going back and forth between cells as you work, because when someone else comes to your notebook, they might not run them in the same order that you do. So to prevent against this, the best thing to do is always stick to a very strict top to bottom ordering when you're writing your code in your notebooks. By that I mean uh, a cell that's lower down should only ever depend on variables and imports which are in cells above it. That's just the only logical thing that's going to happen when someone looks at your notebook and try and run it. The other really big advice is to use restart and run all from the Jupyter menu. And what this does is it will restart the Jupyter kernel. So it will lose this state that normally persists. So you're starting from a blank sheet, and then it will execute all the cells top to bottom in order. And then when that happens, that will be able to tell you if there's any problems, you'll get an error. And the other thing is it's always a good idea to use sectioning. So you can basically if you have maybe several related analysis you want to put into one notebook, you can use Markdown with headings to nicely divide them into different sections to make it clear to people, do they have to start from the very top, or can they actually just go to a different section and maybe that will be a self-contained part that they can run. Okay, so some more best practices. So if you want people to be able to have a nice experience when they're running a notebook, you need to tell them what inputs it needs. Specifically, you need to tell them what it depends on. So if my notebook depends on matplotlib, then the best thing to do is probably put all the requirements for Python packages I have into some requirements file or maybe a conda environment file, so that they can ensure that when they open the notebook, they've already installed in their environment the packages they need to run your notebook. The other big thing is data sets. So it's really important that you signpost where data is loaded from the file system, and you make it clear whether you expect that data, them to have the data you provided, or for them to use their own data. And then in that case, then you tell them what is the format of that data. And if it's a lot of data, that's not very neat to send to a notebook. So one good solution is to put your data on some repository like Zenodo, and then put a URL for people to download from onto their own machine from the notebook. Yes, and another good tip is to basically make everything in terms of importing front heavy. So put it at the very top where it's visible, and then maybe only one or two cells people have to run in order to initialize everything for that notebook. So all the Python imports and all your data loading, if possible, put it into the first cell or the first few cells, so people won't accidentally get half through the notebook and realize they haven't got the right data to run the rest of the code. Okay, so I mentioned earlier that notebooks should be really kept for code that is short and simple. So how do we ensure that, and what do you do if your code is not short and simple? So firstly, this is some basic programming practice. If you're finding yourself reusing the same code between cells, then that's probably indicates you should put a function in and just define a function in the first cell that you can then call in later cells in a single line, rather than having you really don't want to have to repeat code between cells. And if you find that you then have many functions or they're complicated functions, then what you can do is create a separate Python file, so that's a normal Python script, which you will share with the notebook. And then inside the notebook, you just import that Python file as a module, and then you can call maybe all the functions you define in that as sort of your package. And then some sort of more general advice about notebook structure. I would say it's best to not have very long notebooks. They also get quite slow and heavy when you have lots of different things going on. So stick to one or a set of similar analysis in a notebook. Generally, it's quite nice if you don't have lots of a very big chunk of code and a very large amount of text. That can be quite daunting for people to read, and you're going more towards just why don't you just share a Python script or a paper. So yeah, I generally try to alternate between the two formats and really break up things into chunks, into little chunks. And this is going back to the little trick of restarting all and restart and run all. Um, if you want to uh, share your notebook in a fresh state so people can run it and see the analysis happen in action, maybe to their own data, then you always want to clean outputs before you share the notebook. Otherwise, if you have maybe a specific data set that only you have or it's very large, then what you can do is you run the code against that data set, you generate the set of outputs, which are sort of your results you want to share, and then you share the notebook in a read-only format. And I'll explain how you can do that in a minute. But basically, I see notebooks as being there to show the results of your work, not your workbench. So people don't want to see a messy string of cells where you've got sort of various comments and functions you do use, functions you don't use. You really want to pare it back to the minimum stuff which is required to present your results. Okay, so now moving on to some extensions and fun things you can add to Jupyter Notebooks. So I mentioned at the start that Jupyter Notebooks are very good for when interaction is required. And the main way this is done in Jupyter Notebooks is through a Python package called IPyWidgets. So this is just an example from the Jupyter docs of how you can add sliders to a graph to allow people to change parameters and see the result in the model in real time. And the IPyWidgets docs, which is included in that Jupyter package we installed, is quite good, and it shows you easily how you can get up and running with these sort of slider widgets very quickly. Another good option, if you want maybe a bit more sophisticated graph interaction, I would say, is there is also a package called Bouquet, and as you see on the right, they have a number of different widgets and interaction elements, but one which is very nice is they have this little graphing tool which you can add to plots, which lets people pan and zoom and sort of interact more with your data. And for this, you need to install a separate Jupyter Bouquet extension. So I just said a little bit more about those. So JupyterLab, which is the more modern version of Jupyter, has a plugin system, and in addition to things like the bouquet, two other really notable ones are JupyterLab Git, which you can install with pip or conda, and this lets you basically do all the version control things with a Git repository directly from the JupyterLab graphical user interface. I would generally say this is maybe not the best thing to do because of this JSON format. Notebooks really don't version control very well, because you'll make a little change and there'll be a huge diff because all the outputs change and all that metadata in the file changed. But if you really do want to bring notebooks into your version control flow, you can look at using a tool like mbdime, which should let you handle notebook diffs and merges in a much more natural way, rather than just having a huge chunk every time you make a single change to your notebook. And if you in that direction as well, definitely always look at clearing your outputs before you commit a notebook, because there's no point saying you changed a notebook in your version control system where all you did is just ran it at a different time, appointed time. So another really notable extension is Jupyter Collaboration, and this gives sort of a Google Docs style collaborative edit feature to notebooks. This requires a little bit more setup than other plugins. Namely, you'll need a public notebook server, but this could be something if you're interested in using Jupyter Notebooks within your institution or a group of developers. You could ask maybe, is this something your system admins or computing team can provide a public notebook server for you to work together with people and even invite collaborators too. So another really nice tool for Jupyter Notebooks. This is actually going outside the Jupyter ecosystem now. So this is Papermill. This is a external tool for Jupyter Notebooks. And what this does, it lets you work with Jupyter Notebooks from within Python scripts. This is really, in particular, you can basically parameterize and run notebooks programmatically. So this is just an example showing how the Papermill Python package can be used to execute what's called a template notebook, which is essentially just a notebook with basically you put your parameters you want to template out in the first box of the notebook. And what this example does is it'll run through this loop and set volume ID equals 0, 1, 2, 3, and so on. And then it will create an output notebook with with the volume ID variable substituted for that value, and then actually execute the notebook, so run all the cells in it. And this lets you bring your notebook into your actual analysis pipeline if that's what you want to do. Or maybe you've been giving a notebook and you want to by someone else with a sort of demo, and you really want to test it against all your data, for example. So we talked about notebooks and some extensions and enhancements in them, but how do we actually go about sharing them? So that's obviously a really important part. Generally, you can divide these sharing options into sort of two categories. One is sharing a static notebook. So that means it's essentially a read-only copy, and they can't actually run the code on a notebook. So this might be the case when you have a large data set and you want to show specifically your results against that data set. You don't want other people to run the analysis method against their own data. You just want to present your work. So if you put it on a GitHub repository, GitHub actually provides some very limited but still readable rendering of notebooks. Just if you just put the files up there. But otherwise, you can use the MB convert subcommand from Jupyter in the same environment you install the Jupyter package into to convert your notebook into HTML or PDF to share. So the other category is interactive, where you want people to be able to actually execute the code. So within this, there's sort of another two subcategories. One is the case where you don't expect them to be able to run it on their own computer, so they don't have Jupyter installed. And there's a very nice tool called Binder. And what this does is it lets you turn any GitHub repository into basically serving your notebook, which is on that repository, on their Binder servers, so people can actually run the notebook just from the browser without having to do any installations. And it's really simple to set this up. You just go to mybinder.org and enter your repository URL there, and it'll give you back a URL you can actually then include in your GitHub repository as a link. So it's quite common, you'll see this launch Binder button on GitHub repositories. That's just because people have put this URL into a button, so when you click it, it opens up whatever notebook they want you to in this Binder web application. Just continue on from that. The other type of interactive is when you expect them to run the notebook on their own system. So rather than on Binder server or some other remote provider. One option for this, I think I mentioned Voila earlier, but there's also another new project called Lab Constrictor, and these let you turn your Jupyter Notebook into standalone applications. So they don't have to do create an environment or install Jupyter. They can just run them on their desktop, be that Mac, Linux, or Windows, as its own application. So that's really quite a cool way to present your results as a sort of a unit of work. And the obvious one, which is definitely worth mentioning, is you can just send them the notebook directly. Okay, so this even if this JSON file that it's not human readable, if you share it with them, and most people do have access to Jupyter either on their own system or some remote system, then they can just open it and run it themselves. So that's actually probably the main way you might share notebooks. But it's also to if you want to share results more generally, it's also nice to know about the other options of making applications or sharing it via Binder. So just a little bit more advanced topic. We heard from Martin a couple of weeks ago about the containers. So Jupyter provides what's called some Docker stacks containing JupyterLab. And what this does basically, it creates a Python environment with Jupyter and some select packages. So SciPy Notebook is the common one you'd use. So this includes all the normal scientific ecosystem of packages. And this lets you, this is very nice for research software engineers and system administrators because it lets you spin up Jupyter servers very quickly on remote systems and spin them down in sort of a very scalable way. And there's also Jupyter Hub, which I mentioned earlier. And again, this has its own Docker stack. And this is for serving multi-user JupyterLab instances. So that one's more useful for system administrators. But there's no reason you can't use Docker to run JupyterLab because that's probably the quickest way to do it. And you just have to remember to assign the port so you can still access it on your own system, your own browser. Okay, so just before I finish, I want to talk about some alternatives to Jupyter. So there are a whole host of what I call collaborative platforms, like Google Colab, DeepNote, and Kaggle. These actually have their own document formats, which may or may be more or less compatible with Jupyter Notebooks. And they each have different features, but then the sort of primary thing is you work in the cloud, and there's normally some collaborative aspects where you can share notebooks or work in real time with other people. And then another project I definitely want to highlight is one called Marimo. So this is a very new project, but it's gaining a lot of traction. And this is a new notebook provider, so it essentially is a replacement for Jupyter, but it's far more modern and it has a number of very nice features. So, for example, the underlying files are not JSON, but they're just Python. And this makes them very easy to version control, for example, and easier to read if you're not in a notebook environment. They solve some of the issues about the persistence of state we have with Jupyter Notebooks, and they sort of have inbuilt features which you'd have to go to extensions for Jupyter Notebooks. So like the feature of executing the notebook like by paper mill, that's included. They're also nicely testable. Like Jupyter, they can run in the browser, and you'll be pleased to know that they also have basically an AI first system, so you can connect these up to your favorite LLM provider and have that generate code blocks for you directly within the notebook. There's also a sort of chat functionality. So yeah, I definitely recommend looking at these if you're interested in starting to use notebooks in your workflow and you're not tied for Jupyter Notebooks for any particular reason. So with that, I'll just give a quick summary. So notebooks are really great tools for sharing research outputs, and they're particularly good when you have data exploration or visualization. They aren't necessarily the right choice when you have more complicated code or long sets analysis. But as I said, there's ways to move that into a sort of back end of different Python files, or perhaps you just share a read-only version of a notebook. There's this check you should run of restart and run all to check that the order of your notebooks is going to run from top to bottom and not hit any issues. We've covered lots of different extensions you can add to Jupyter and tools such as paper mills. And we talked about some alternatives such as the cloud platforms, but also this Marimo for an entirely new notebook ecosystem. Thank you for listening.
Lovely. Thank you so much, Piper. There was so much there to think about. I have been furiously scribbling notes throughout your talk, so I have now got a massive Word document of ideas and thoughts from that. Right, first question. So we have about 15 minutes or so now for some questions from the audience. So if there is anything that you would like to ask, please pop it in the Q&A box. I know we've had a comment within the Q&A from Mariam earlier in the talk. Mariam, if I unmute you, I wondered if you'd be able to jump in with the suggestion that you made. I thought it was it seemed like quite a helpful thing to share. I've unmuted you, or I've given you permission to talk, so you're able to unmute if you'd like to jump in. Give Mariam a second.
If that doesn't work, I also understand what she's suggested, so I can also cover it. But we'll see.
Yeah. Okay, wait a second. I think we can maybe think that she's not there. Yeah, so Piper, if you want to
Yeah.
jump in with that.
So yeah, when I was covering earlier that you had to keep the terminal open when you start the launch of Jupyter server. If I can just go back into find my terminal. So I'm going to stop this by pressing Control C. Is that in the terminal, if you want to, there's a way of forking a process into the background. And what this does is it lets you keep using the terminal while the program's running. So, and that's just adding this ampersand symbol when you run the program at the end of the command. And what you'll see is that you can actually it's just started up the Jupyter server again. But if we go back to the terminal, I can actually still interact with this, though it is going to be filled with Jupyter Notebook debug. There's also a way of doing getting rid of that as well. But I would probably suggest just yeah, maybe having two terminals open.
Fab. Thank you, Mariam, for that suggestion. That's really useful insight. We have just had another question in from Hannah Grobe on the Q&A, and they ask, what is the best or most stable way to ask for input from users in a notebook?
Yeah, so what I would suggest is I think I had a note, yeah, a little tip here saying about placing things at the top of the notebook. So I would suggest having at the very top of your notebook a box, which could be just defining variables you want them to put in. Maybe it's a path to data, and you have to explain what format you expect the data to be in. Um, but yeah, just signpost this at the top, and then once they run that and define their variables for the rest of the notebook, then those variables will persist for all the cells they're needed in.
Great. We've also had another question that is volume EM datasets are very large. What's the best practice to share those huge datasets with notebooks?
Yeah. So that's also on this slide, actually. Yes, it's definitely a really good question. So it's, yeah, as you guess, it's not practical to send huge amounts of data with your notebook, and that sort of defeats the purpose of having something which is lightweight and shareable. Um, so there's sort of two things I would say. One is, do you really need to actually share the whole data set? So it may be the case that you can work with just a subset of your data to illustrate your methods, or sort of as an example, and leave sort of the big processing results that's just results you present rather than actually sharing the data. The other thing in that other point in that direction is that often it can be for certain data you only need to actually show summary statistics. For example, if you're just you took a data set every month and you might be able to just use the mean or other statistics, which is actually a very small amount of data compared to the original data set for a plot. If you're in a situation where you really do want to include data, then as in the full raw original data, then yeah, I think your best option is to put it on a remote repository like Zenodo or Git large file system, and then say clearly a notebook, here is where you can get the data I used in this notebook from if you want to run it yourself.
Great. I had a question for our audience. If anyone would like to raise their hand, I was curious to know whether anyone is using notebooks as part of your pipeline. It would be interesting to know what you found them useful for, what have they not been useful for as well. And it would perhaps be interesting to know whether there's anything that you would like technical input on, we've got 10 minutes. So if there are specific questions that you have in relation to your own use of notebooks for your own research, I'm sure Piper would be happy to chip in with some technical guidance.
Yeah, while people are coming up with ideas for me, I could say for me personally, the I don't use notebooks in my own
Mhm.
computational workflow, but where I found them most useful is for actually the teaching and tutorial type things, because they're a very good way of sharing code and explaining code without just sending endless scripts to people, because you can really structure things and get them to sort of go through exercises and fill in the blanks.
Yeah, that was going to be one of the questions I was going to ask you was where in your own working day would you
Yeah,
use notebooks and how you would parse out, well, this is a notebook problem, this is a different problem.
yeah, yeah. So yeah, generally where I encounter them is actually helping other people with their notebooks, rather than myself. Um, and yeah, it is often the case that when people are saying, "Oh, I know what's not running," it is often a notebook issue because they have either running things in the wrong order and they're missing an import statement or some other data set dependency, and or normally they're trying to load data and the path for the file they're trying to load is not correct. This is especially true if you're on one of these collaborative platforms like Google or some online Jupyter server, because you have to make sure you upload the data to the right directory compared to where you're running a notebook, because otherwise the path won't work. That's why I mentioned at the beginning, it's important to run the Jupyter command somewhere where you can access your data in your notebooks, to give you the best chance of getting that right.
Yeah, yeah, it's interesting that you raised those points because the thought that I kept coming back to in that context was that um, the notebook ecosystem seems like a very powerful way of onboarding people that aren't very familiar with coding by the way in
Yeah,
which it forces you to think in such a modular way. And like you said, to think about code that you're repeatedly using, converting that into functions.
yeah,
It seems like a good ecosystem to play with if you're not at a point yet where you would be thinking about creating software, but instead writing code to solve small challenges and do data exploration where you might not quite know what it is that you want to do yet, um, but to be playing around with the data and your code.
yeah. I agree. That's a really good use case for notebooks, I think.
Mm, mm. Do you find, so where within the analytical pipeline do you find that people most frequently use notebooks? Is it typically at that exploration phase, or have you encountered powerful applications of notebooks, say with publication, because it does obviously support that
Mm.
reproducibility? There are some brilliant functions there in terms of creating interactive ways to play with the data that you're
Yeah,
presenting. I can see that being really useful in publications. Do you see that frequently?
yeah. So I guess basically the observation is that the notebooks come often at the very beginning or the very end. So you'll either just want to quickly enter something and pan through your data and see what's there, before really committing to writing some sort of structured program to maybe analyze all the bulk of your data. And at the end, they're really great for just presenting some select results, and maybe some your methodology, um, as a research output.
Yeah.
Yeah, yeah, I generally often see those. I mean, I would hope to see them more with publications, but
Mm.
getting code and scripts accepted as sort of a research output is very challenging. I mean, opinions are changing about academia, but it's still quite difficult to people are very focused on papers. Um, but definitely when it comes to presentations and live demonstrations and other more interactive ways of sharing things at conferences and events and workshops, then yeah, they're definitely a more common tool there.
Mm, mm. And I guess kind of related to that observation, um, how do you see the future of notebooks within the research space? Do you think that this is something that will grow as we move towards thinking about how to share our code or our analysis in a reproducible, accessible way. Do you think that this is a domain that's growing at the moment?
Oh, that's a super difficult question. Um, I think it's possible, but I think also because of how powerful AI agents are at being able to write scripts and not maybe necessarily need to go through some of the extra steps people have to write a notebook. Um, because ironically, writing a IPython notebook file for a LLM is more difficult than writing a Python script because you have all this extra JSON object notation to get around. Um, but yeah, in general, I think if we have a nice trend of code and software being recognized more as research outputs than just publications alone. And I think there are journals which are like JOS, which are more suited to this, and that's really great. Then yeah, notebooks seem like they can be a good piece of that puzzle to go with that trend.
Mm, Yeah, I guess it's a challenging time to make predictions about code in the era of AI, isn't
Yeah, yeah, definitely.
it? Fabulous. Okay, well, we're just running up into the last couple of minutes. So perhaps my final question will be if someone in the audience only took one idea about notebooks away with them today, what would you hope that would be?
Um, that Notepads, like everything, are a really good tool, but that also means that they're not well suited to all use cases. So I do often see people trying to maybe do a bit too much in notebooks just because that's the only thing they're used to using. But you definitely have to recognize when, okay, this really isn't feasible for me to be running my entire analysis pipeline in a notebook. And I just need to, yeah, think about using it, as you said, at the beginning stage or the end stage, either explorating or presenting your results.
Mm. Mm. And if you found people were encountering that problem, what would your suggestion be to start thinking about passing it into separate notebook systems or a different ecosystem?
Um, yes, normally I would recommend going the route of looking at is there a Python script or pipeline I can write or to do this instead, um, because that's going to be for complex code that's going to be a lot easier to repeat and run, I think.
Great. Well, thank you so much for all of your insights and for your time today, Piper. Really appreciate you taking the time to put together that talk and share it with our
No,
community.
thank you for leading the session, Helen. It's really great.
Thank you. And we will be having another show and tell. Provisionally, it's earmarked for the 19th of May, I believe. To be confirmed, I'll be sending details around on our mailing list and via our website and all the comms channels. So keep your eyes peeled for notification of that coming through. And thank you to everyone in our audience for spending your lunchtime with us. Take care. Thanks again, Piper.
Yeah, thank you. Bye all.
Bye.